Huygens principle. Christian Huygens was born in 1629 and died in 1695. He is best known for his contributions to the field of optics and dynamics. He thought light was a type of vibratory motion, and it spread out and produced a sensation of light when it hit the eye. He deduced the laws of reflection and refraction, and he also explained double refraction. So in order to understand Huygens' principle, first we have to talk about ray optics. Ray optics, sometimes also called geometric optics, involves the study of the propagation of light. It uses the assumption that light travels in straight line path in a uniform medium and changes its direction when it meets the surface of a different medium or if the optical properties of medium are non-uniform. Ray approximation is used to represent beams of light. Rays are straight lines perpendicular to the wavefronts. With the ray approximation, we assume that the waves moving through the medium travel in a straight line in the direction of its rays. So for example, if you were to consider rays traveling forward, light rays, the wavefronts would be these, and then the rays would go forward in the direction. Huygens theory, also called diffraction theory. So Huygens theory says that as the wavefront propagates along, it produces point sources which emit spherical waves. As long as all these point sources start at the same time and are allowed to emit waves without interruption, the wavefronts along the direction of propagation is a straight line. If an obstruction or barrier with a slit intrudes, however, then some of the spherical waves are blocked and cannot contribute to the wavefront. The response is that the wavefront becomes curved. So these he called wavefronts. These are the spherical wavelets, and this is the propagation of the wave. So these would be called wavefronts. The line going forward will be where the light rays are going to. So case 1, when the obstruction is much larger than the wavelength. If the obstruction or opening is much larger than the wavelength, part of the wavefront that is allowed to continue does so with the wavefront remaining straight. So for example, this one. If you have wavefronts coming towards a barrier, so think about this as a barrier in water, for example, and these are going forward, they will continue to go straight through without no hindrance. Same thing if the barrier was instead this way, the waves will get stopped. These wavefronts will get stopped. These wavefronts will continue forward. Now what about the case 2, if the size of the opening becomes comparable to the wavelength? The waves proceed to bend through or around the opening or obstruction. For example, in this case, they will become spherical waves as they propagate forward. Or in this case, the waves that are away from the barrier will continue to go straight. However, the waves really close to the barrier edge will become bent, whereas the rest of the wave will get stopped. So when light encounters a barrier, such as a slit, its path bends and it can illuminate areas behind the slit that are larger than the width of the slit, just like this animation is showing.